Hey everyone, welcome back, and today let's solve LeetCode problem 2116 titled Check if a parentheses string can be valid. So a parentheses string is basically a non-empty string consisting of only closing and opening parentheses. And it is valid if any of the following conditions is true. It doesn't have to be all of them, it just has to be at least one of them. So the initial case for this input string s to actually be valid is if it's simply just a opening parenthesis followed by a closing parenthesis. Or it can also be written as AB, where basically A is concatenated with B, where both A and B are valid parentheses strings themselves. And lastly, it can also either be written as a string A and then a closing string, where A would be a valid parentheses string, right? So basically, again, to reiterate, we'd have an opening parenthesis, we'd have A where A is valid, and then we'd have a closing parenthesis for that specific string. So we're given a parentheses string s and a string locked, both of length n. And locked is going to be a binary string consisting only of zeros and ones. Note that these are in the forms of strings, not integers, for this input string locked, right? And for every single index I of this input string locked, if locked at the current index I in that iteration, if it's equal to a 1, well then we're not allowed to change s at that index I. However, if locked at I is actually equal to 0, well then we can actually change s at that index I to be whatever we want. In this case, the two options we have would obviously just be the opening or closing parentheses, whichever one we'd prefer at that specific iteration to make our input string s potentially valid. So we need to simply return true if we can make a string s a valid parentheses string. Otherwise, we have to return false. And note that again, s is simply our input string. So in example 1, we have our input string s to be to closing a valid a, or rather a valid opening followed by a closing, like we saw as the first constraint, and then followed by that we have a closed. In this case, our input string locked is going to be the same length as s. In this case, that's going to be a length of 6, and we have 0, 1, 0, 1, 0, 0. And what these zeros and ones really mean is basically what this is really telling us is that for the first and third index of this input string s, we cannot change it. However, for the rest of the indices or characters at those positions or indices in our input string s, we are allowed to change them because locked at those indices are actually equal to zeros. They're basically non-ones. And in this case, the reason why our output is true is because we can actually make this valid with some number of swaps or some number of operations, right? The reason why is because locked at 1, the first index, technically second if you're going by a one index based approach, but technically one indexed, or rather this is 0 indexed, locked at index 1 we see is equal to 1. And locked at index 3 is also equal to 1. Again, that means we cannot change s at those indices either, which is basically s at index 1 at index 3. But what we can change is all the other indices in our input string s for us to actually make our input string s potentially valid. And the way we would do that is basically changing s at index 0, the initial string here, from going to a closing to an opening. And then what we can do after that is actually basically find out that we can then change this guy over here and make that an opening. And then if we do that, we would see that we would get a valid parentheses string s. And to put that into simulation, let's go ahead and look at the code base here. Sorry about that, guys. I was just trying to... Okay, anyways. Basically, what I was saying here is if our input string s would be equal to something like this, we could change this s at index 0 to basically be an opening parenthesis, because locked at index 0 is equal to 0, not 1. And then we can change... Oh, sorry, looks like I added an extra 1. And then we can change this guy down here, basically s at the last index to be... Or rather, sorry, these should be both like that. And then I can change s at the second to last index, that is, to go from a closing to an opening string. And then we would see we were allowed to do that because locked at that index which is in this case going to be the second to last index, is also equal to 0. So we're allowed to change it. And as you can see, this is now valid. This is a valid string. As you can see, we didn't delete or remove any parentheses. This still has a length of 6. We simply swapped some of the characters kind of greedily that we wanted to switch to make this a valid parentheses string s at whatever indices that locked was not locked, right? Which we actually needed to switch. In example 2, we have our input string s to be the following, and in this case, we can change any parentheses at any indices we want because all of these strings or characters in our input string locked are all zeros. But in this case, we don't even need to make any changes regardless because as you can see, this input string s is already valid. And so we can immediately return true. We don't need to make any changes because it's already a valid input string s. And finally, for example 3, we have our input string s to be literally just a single character, in this case a single parenthesis as a closing parenthesis, and locked to be 0. So although we can change this closing parenthesis, it doesn't matter, right? So although locks actually does permit us to change this, whatever we do, we can't actually form a valid string s because it's very, very important to note that I have nothing to counter or mirror this with. I can either open this or close it, but I don't have something to do the opposite of. So I can either have something like this, but I won't be able to close it, or I can even have something like this, but in this case I wouldn't be able to open it. With only one parenthesis, I can't actually form a valid pair, because a valid pair to make the input string s valid is where we have a pair of one closing and one opening for it to be something like this, for it to actually be valid as a string s. Okay, so for the constraints here, we see that the length of our input string s is always going to be the same value as the length of our input string locked, which is nothing but n, is how this is denoted in this problem here. And we see that n, the length of these two input strings, are never going to exceed 10 to the 5th power, which note in runtime and memory time complexity is a pretty large number, and at least relatively, and s at index I is always either going to be a closing or opening parenthesis, which is pretty good to know. It kind of tells us that we won't have any weird invalid inputs like numbers or hashtags. We're always going to have valid inputs and we don't have to deal with those edge cases. And finally, locked at any index I is either always going to be a 0 or 1. Again, it's always going to be a valid input. So with the problem statement examples and constraints out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution. And then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so like we were talking about in the last example here with the single parenthesis that we couldn't close or open at any iteration, that kind of leads us to one very important observation that we can make. But before that, what is very important in really understanding how this problem works? Well, the key here in this case to really understand how a valid parenthesis strings works is that every closing string always must have a corresponding opening string before it. Without that, we can never make it valid, of course, unless we're allowed to change it. But if we don't have something to mirror it to make it a valid pair of an opening and closing parenthesis adjacent to each other, where the opening comes first, there's no way we can make the input string s valid, right? And so that kind of leads us to the major observation that we can really make about this problem. And that really is that one thing that we should note about parenthesis strings is that they're always going to follow a balance. They're always going to be mirrored perfectly or symmetrical in some way, right? Not throughout the entire string, but they're always going to have a balance of valid pairs of parentheses, which really means is that if any point the number of closing parentheses exceeds the number of opening parentheses, we know that the string cannot be valid. Okay, we know that because we want to start or open with the opening parentheses, right? So basically for a high-level rundown of how our solution is going to go, basically we're going to traverse the string twice. We're going to basically have a two-pass solution with two for loops here. In the left to right, or rather in the initial for loop in the first iteration, we're going to check from left to right and make sure that there aren't any more closing strings than there are opening strings for our input string s to actually be valid. And we're also going to go from right to left in the second pass or the second iteration to make sure that there aren't more opening parentheses than there are closing parentheses. And as long as those two constraints or conditions aren't ever true at any iteration in both of those one-pass solutions or one-pass for loops there, we should be fine and we can return true once that's done, right? And to do this, we're actually going to maintain counters as well during each of these traversals to actually check the balance. And if the string passes both the checks, we know that it is going to be valid and we can return true. So with that high level rundown out of the way, let's go ahead and dive straight into the code here. So first of all, what is very important to note about this problem? Well, that is, again, going back to our original observation and the key understanding part of this problem, we want this to be balanced. And one way that our input string S would not be balanced is it has an odd number of parentheses. Because think about it. Every single valid pair of parentheses always comes in pairs. We can't, like we saw in example 3, we can't have a single parenthesis like this. We can't have a single closing parenthesis or a single opening parenthesis. It won't work. Why? Because in this case, we wouldn't have anything to close this with, and in this case, we wouldn't have anything to open this with. We always want it to come in pairs, and so we always want our input string S to have an even length, so that we're always going to have the same number of opening parentheses as we do closing parentheses, so we can open and close all the parentheses for our input string S to be valid. We don't want to have more opening parentheses, nor do we want to have more closing parentheses, because then we'd have an imbalance. We wouldn't have a valid input. That's very important to note for this problem to even be able to solve it in the first place. So what our initial condition is going to be to avoid any redundant computations here, if the length of our input string S isn't even, so if the result of its modulus, or the remainder of it when you divide it by 2, if that's equal to 1, well then we know we immediately would have to return false. Because again, if the string is odd, we cannot actually form it to be a valid string, right? The string must have an equal number of opening and closing parentheses, its length must be even, and so we can immediately return false because it's going to be impossible to balance the parentheses. Okay, now that we've actually covered that kind of initial base case there, now let's actually go into initializing our left and right balance counters to go for both the passes of the solution. So first of all, let's initially initialize or declare our left balance. This is going to be equal to 0. And let's kind of talk about what this integer variable really is kind of doing here. Basically, it's going to track the number of opening parentheses and the number of closing parentheses while we're actually traversing through the string from left to right in the initial pass, and that's going to make us kind of verify that at no point do we have more opening parentheses than we have closing parentheses, because of course if we do, that would make our input string invalid, which we of course we're trying to verify in this problem here. Okay, so now that we've actually initialized this left balance to help us do that and actually ensure that, now let's actually initiate or instantiate our for loop here for left to right, our initial one pass solution, to actually check if we have more opening than closing parentheses. So for I in the range of the length of our input string S, simply going through every single index in this input here for this string for all the characters at those indices, if S at the current index I in this current iteration, if it's equal to an opening parentheses or locked at that current index I, again I is simply our index, if that's equal to the string 0, well then we know we can increment our left balance by 1. So left balance plus equals 1, very simply, in Python. And what we're really doing here is basically, well, if the current index I, so if the current element is actually equal to an opening parentheses, or we're actually allowed to change it, well then we know we can have a left parenthesis at this index, and so we can increment the number of left parentheses by 1, which, or in other words, our left balance. It's basically the number of kind of closing parentheses for the left to right iteration by 1. However, if this is not the case, well then we want to decrement our left balance by 1, kind of for that balance property here, so left balance minus equals 1. And finally, for our last condition, if the left balance ever, I don't know what I think it's decedes, I'm not 100% sure. If it ever goes below 0, so if it ever becomes negative, we immediately will want to return false. At any iteration or at any point of time, if this is true, if our left balance becomes negative or less than 0, we have to return false. Let's really break this down, because this might seem a little bit confusing. I wanted to kind of finish the one-pass solution before actually explaining them beforehand. Okay, so what are we doing in this initial left to right for loop here for the initial pass? Basically, after iterating through every single character at every single index in this input string S, first of all, if the current character at this current index I, if it's equal to an opening parentheses, or if it's unlocked, meaning we can actually change it, so locked at I is equal to 0, well then we have to increment its left balance by 1. However, if it's a closing parenthesis, so in the else condition, and it is actually locked, that means we have to then counterattack that for the balancing property and decrement the left balance by 1. for that kind of balance between left and right closing parentheses, or rather I should say opening and closing parentheses. However, at any iteration, at any point of time, if this left balance is actually goes below 0, well then we know there are too many closing or rather opening parentheses, and so we have to immediately return false. Okay, once we've computed that initial pass there, if we haven't returned false yet, now let's move on to the right balance for the right, or rather for the closing parenthesis check for the second pass of the solution. And what this right balance counter as such is going to do, basically it's going to track the balance of parentheses again while traversing the string, in this case, not from left to right, but rather from right to left. And that basically makes sure that we don't have more closing parentheses than we do opening parentheses, or rather that ensures that we don't have more opening parentheses than closing parentheses in the reverse direction. Okay? Again, to reiterate, I'm going to say this a little bit more slower. What this second pass is going to do here, basically we're still going to make sure that we don't have more opening parentheses than we do closing parentheses, but in this case we're going in the reverse direction, not from left to right, but rather backwards from right to left. Okay? So now let's actually instantiate that second pass. So for I, in the range, in this case, we're going to go backwards. So a good way to do this in Python, pretty simple here, is we're going to start from the last index, which is the length of s minus 1. We're going to go up until negative 1 exclusive, or basically the 0th index till the beginning of the array, or rather the string. And we're going to decrement by 1 at each iteration, basically going to the left at each iteration, decrementing by 1 for every single index for every single iteration. Now, very similar approach here. If the current index, if it's equal to an opening parentheses, or it's actually unlocked, meaning that lock.i is equal to 0, we can actually change it, well then we know that we immediately, it should be outside, we know we immediately want to increment our right balance by 1. In this case, not left, but rather right. Because of course we're going in the left direction now. We're going from right to left now. However, if this does not hold true, so in the else conditional, if it's not an opening parentheses or it's not unlocked, well then we want to then counterattack that for the balancing property and decrement the right balance by 1. And if at any point at any iteration, once we're doing these computations on line 19, if these computations are over and at any iteration our right balance goes less than 0, so less than 0, we can immediately return false. As you can see, very, very similar structure here. Oh, sorry. I don't know why. This is all in the code here. Let me actually... Okay, so, sorry about that, guys. I actually forgot to unindent. This should all be unindented. Okay, so as you can see, again, very similar structure to the initial pass of the solution. We're basically just going in the reverse direction. Again, if you guys didn't get it yet, the memo, I'll kind of reiterate what we're doing here. Again, in this case, now we're iterating through the string from the last character up until the first character. And in this case, if the character is actually a closing parenthesis, right? So if it's actually a closing parenthesis, or it's unlocked, meaning lock.i is equal to 0, well then we have to increment our right balance by 1. Okay. However, if that's not the case, so that means if it's actually a opening parenthesis and it's locked, so locked at this index I is equal to a 1, well then in that case we know we have to actually decrement our right balance by 1 for that balancing effect. And finally, if the right balance at any point in time goes below 0, well then we know there's too many closing, or rather there's too many opening parentheses, then we have closing parentheses, and so we have to return false immediately at that specific iteration. But if we never return false for any of these passes, for any of these iterations, we then can return true at the end of the code once both of the for loops are done executing. Because what that really means is if the string actually passes both the left to right and right to left checks, we know that the string actually can be valid with these switches or these swaps, and we can eventually return true. So unless I made any syntax errors here, this should be accepted and this should be a valid solution. So let's go ahead and check it out. And as you can see, this is really just about as efficient as you can get. Okay, so for a quick high-level rundown of how our solution actually works and what we're really doing here, basically, if we don't actually have an even length, that means we can't balance it because we wouldn't have the same number of opening and closing parentheses, and so we can immediately return false. However, if we don't return false, this is where we actually start our two-pass main chunk of the solution. Basically, we're checking the string we're checking the string twice using two balance counters from left to right and right to left iterations, where the first pass is going to make sure that from left to right, the string does not have more opening parentheses than it does Basically, what the first pass is going to make sure is that from left to right, the string does not have more closing parentheses than it has opening parentheses, and the reverse. The second pass is going to make sure that from right to left, the string does not have more opening parentheses than it does closing parentheses. And finally, if the string passes both of these checks, then it means it can actually be valid, and we can actually return true. Otherwise, we have to return false in that iteration if our left or right balance ever goes below 0. So let me actually comment that out so you guys actually understand. Sorry, I've kind of been mixing up opening and closing here. Basically, the first pass is going to make sure from left to right we don't, okay, there should be space there. We don't have more. In this case, it's going to be opening parentheses, I think, or rather, sorry, this is a closing parenthesis. As you can see, guys, I'm very good at mixing them up. Then opening parentheses. And what the second pass is going to do, which basically means a for loop here, the second for loop pass is very, very interchangeable for for loop here, is going to make sure from right to left in the reverse direction, in this case, we don't have more opening parentheses than we do closing parentheses. Okay, I finally got it right. That's good. And finally, if the string actually does pass both of these checks, if it passes both of these passes here, both of these for loops, it can actually be valid after some number of swaps from the locked string, and we can eventually return true. Okay, so for the runtime complexity of the solution, this is actually going to be a big O of n solution. Why? Because, of course, we're really just running two linear passes over the string. They're not nested, and so technically it's big O of 2 times n, but really fully simplified, it's just big O of n because we don't care about constants and coefficients in runtime and memory complexity. And so this is going to be a big O of n solution, where n is simply going to be the length of our input string s, and the space complexity, or the memory complexity, is actually going to be, believe it or not, big O of 1, because we're really only using a few integer variables. We're not using any auxiliary memory or any extra data structures, and so this is actually going to be a big O of 1 or constant time solution in terms of space. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.